Today we are going to continue with section 11.3, vectors in the plane, and we're going to continue by finding the dot product. Now, the dot product of two vectors, vector u and vector v, where vector u has the components a, b, think of that as your x and your y, and your vector v is cd, is denoted by the following. Now, be careful. In this case, that is not a multiplication. That is a dot. And it's read u dot v. And it's given by the following equation. So the dot product is going to be AC plus BD. So it's a very easy process. And we are going to be using this in the following example. And as you go into high level math, you guys will be taking a class where you guys will be doing vectors and that'll be linear algebra. But for now, to find the dot product is a very easy process. So the dot product will be 2 times 4 plus 3 times negative 1. So therefore that gives me 8 minus 3. So the dot product will be 5. In this case, we're looking for the dot product of those two vectors. Notice whether you have it in this form or in this form, you'll be exactly the same process. We are going to multiply your a values. So for 4 will be 6 times negative 2 plus 4 times 3. That gives us negative 12 plus 12. So therefore your dot product will be 0. So now let's go and find one of the uses for a dot product is the following. Example number 10. Go and take time to copy it down, go and pause it, and we'll continue once you're ready. So we can find the angle between two vectors. If theta is the angle between the two non-zero vectors, u and v, in this case this should be a bold u and v, where the angle is between 0 and 180, then the following holds. The dot product will be equal to the multiplication of u times v, and just be careful. In this case, this is a multiplication, and that is a dot. Multiplied by the cosine of theta. Or we can actually write down cosine of theta is equal to the dot product of both vectors, and then you're going to multiply the magnitude of each of the vectors. So let's go and find the angle between two vectors. So therefore will be the cosine theta. First, we need to be able to find the dot product. So u dot v with 3 times 2 plus 4 times 1. So it'll be 6 plus 4 will be 10. Over, we're going to find the magnitude of each of the vectors. So the magnitude is the length of the vector. So therefore, let's go and find the magnitude of u. And you have to be able to remember that your magnitude is the square root of a plus the square of a squared plus b squared. So the magnitude of u will be 9 plus 16 will be 25. So therefore your magnitude of u is 5. Now be careful, sometimes some books will have it as a bar, some other books will have it as a double bar, which will be exactly the same. So therefore will be 5 times and let me place it in parentheses instead. Now I'll find the magnitude of v. So it'll be 2 squared plus 1 squared, which will be 4 plus 1 will be 5. So the magnitude of v will be the square root of 5. And now we can just simplify it. I can reduce my 10 and my 5 to be 2. So therefore the cosine of theta is equal to 2 over the square root of 5. I can take the time to rationalize it, but in this case I just need to be able to solve for the angle. And 2 over square root of 5 is not one of the angles that we know. So therefore I need to use my calculator. I want to make sure that I have it on degrees, and I do in this case. So therefore I'll be the cosine inverse. I'm going to use my fraction bar. 2 over square root of 5, or if you want to be able to rationalize it, you can do 2 square root of 5 over 5. And now it gives me an error. So let's see, why did it give me an error? Well, there you go. That'll be 26. So therefore, my angle is approximately 26 point, let's just leave 2 decimal places, 26.57 degrees. Now one of the things that we can do, we can actually just, let's make a quick sketch right underneath, right below it, and see if we can actually confirm that that is the correct angle. So let's make an X and Y axis. Remember that whenever you have your vector here, it's already in component form, so therefore your initial is at 0, 0, then this is 3, and at 4, that is your ending, your terminal point. This will be 2 and 1, and therefore initialize it at 0, 0, and at 2, 1, and then you can confirm, does this look like a 26.57? Correct. So therefore that is correct. Letter B. So take the time to be able to find the angle, go and pause it and see what you get. And then we can compare our answers. Excellent. So in this case, I need to be able to find the angle. So the cosine of theta is equal to the dot product of u and v. So be u dot v, where that'll be 2 times 6 plus negative 6 times 2. So therefore it'll be 12 minus 12, which will be 0. And now I'm going to multiply the magnitude of u which is 2 squared plus negative 6 squared. So therefore the magnitude of u will be 4 plus 36 will be square root of 40. And I can simplify as 2 square root of 10. But in this case, I'm going to multiply them out, so I'm just going to keep it as square root of 40. And I'm going to do the same thing with v. V will be 6 squared is 36 plus 2 squared is 4. So therefore, the magnitude of v will be the square root of 40 as well. So in this case, we have a 0 on the numerator, so therefore we're looking for the cosine of theta is equal to 0. Now 0 for cosine is one of the angles that we know. So therefore theta will be equal to 90 degrees. And you can also use your calculator if you do have it, so you can do the cosine of inverse cosine of 0 will be 90 degrees. So let's just do a quick sketch and then we can talk about the answer briefly. let's see, 2 and 2, of course, not -6, so we'll be done here. And 2, 4, 6, and up 2. 1, 2, 3, 4, 5, 6. So we'll be around here. And we have it here. And one of the things that you need to ask yourself, does this look like a 90-degree angle? It does. So therefore, that is correct. Now, there's a theorem that tells you that if your dot product is 0, because there's 0 on the numerator, automatically, this will automatically be 0, which is going to be 90 degrees. So every single time that your dot product is 0, then that means that those two vectors, the angles in between, is going to be 90 degrees, or we can say that those two vectors are orthogonal. So now let's continue to example number 11. Now we have done air navigation before, so take your time to copy it down, and then once you're ready, in example number 11, and then we can continue. So in the air navigation, in surveying and navigation, directions can be given in terms of bearings, and we've done bearings before. In air navigation, bearings are measured in degrees clockwise from the north. So bearings are measured in degrees clockwise from the north. So for example, 60 degrees. We're going to start from the north and we are going to go towards the right, clockwise. So 60 degrees, I'm going to place my two dashes just like we've been doing. That'll be 30, 60, and that'll be my direction that the plane is going to go towards. And remember that to place your little arrow, and that'll be 60 degrees. 220 degrees. The bearing will be from the north towards the right. So 220 degrees, that'll be 90, 180. How many more to get to 220? Correct, 40 more. So this is 45, so just a little bit less. So 180 and 40 more will give me 220 degrees. $120 degrees. So we're going to start from the north and we're going to move towards the right. So this is 90, and how many more to get to 120? 30 degrees more. So it'll be two dashes. So therefore we're going to go towards and that'll be 120-degree bearing. So from the north towards the right. Now, example number 11. A ship leaves port on a bearing of 28 degrees and travels 8.2 miles. The ship then returns due east and travels 4.3 miles. How far is the ship from port and what is its bearing? So one of the things that you have to be careful is when you're doing this drawing is that you have to make sure that you are as exact as possible with your rotations. So a ship is going to leave port with a bearing of 28 degrees. So you're going to start somewhere in the middle. Look a little bit more. And I'm going to place my X and Y axis and I'm going to place it as a dash. So this is where I'm starting. And you always want to be able to place a X and Y axis from the place that you are turning from. So this is your location. And a bearing of 28 degrees, there's no north, east, west, south. So therefore it's going to go from the north towards the right. So from the north towards the right will be 28 degrees. So I know that this is 30, 60, So 28 will be just a little less. Now, one of the things that you have to be careful with is that you always want to be able to make sure that you get, when you make your line, you want to make sure that you get to a point on the grid. It'll make your work much easier to find that corresponding angle that you need. Either here or here. So it's 20 degrees, I'm going to go up here. And it travels for 8.2 miles. So let's go and label our rotation. This is 28 degrees. And this is 8.2 miles. Then the ship is going to turn due east. So never ever eat soggy waffles. So this is east. So, but that's going to go from here. So from here, I'm going to place a new X and Y axis. That'll be from the new location. And it's going to go towards the east, so it's going to go towards the right. It's going to go 4.3 miles. So it's going to be about half the distance. So either here or here. Now remember that you always want to be able to keep it to a point on the grid. So I'm going to go to here. So I'm going to make it turn east, and that's where I'm located. And this is going to be 4.3. How far is the ship from port? So the first thing that we need to be able to figure out is the distance from your current location to where you started from port. And we're going to label that as X. That's what we need to find. Now, in order to be able to find, when we have the triangle here, and we have two sides. So therefore, I need to find either one of those three angles. So see if you can take some time to find the missing angle. Go and pause it. Did you find it? So let's say this is 28 degrees. So therefore, I can find this thing. This is a 90-degree angle. So therefore, this is a right triangle. That's 28 degrees. Plus how many more makes it into 90? So therefore, this will be 62. Do you agree? 62 plus 28 plus 90 should be 180 degrees. So therefore, that's correct. And therefore, I know that these two angles are going to be a linear pair. So I'm going to do 180 minus 62 will give me 118 degrees. So therefore, that will be 118 degrees. Now the math to find the value of X, that is the easy part. The difficult part for you guys will be to be able to make a correct sketch, an accurate sketch. So let's go and find X. Now remember that whenever you have, the way I remember whether do I need to use the law of sines or the law of cosines, I cannot use SOHCAHTOA on this triangle because that's not a right triangle. And I cannot use Pythagorean theorem because that's not a right triangle. But I know that I have two sides and the angle in between, so therefore I can use the law of cosines. The law of cosines will be x squared is equal to one side plus the other side minus 2. Those two sides get repeated, 8.2, 4.3, and the cosine of the angle in between, which is 118 degrees. From there, I can just type into the calculator. And what's nice about this calculus that we have now is that we can type everything at once. So therefore, it'll be 8.2 square plus 4.3 square minus 2 times 8.2 times 4.3 times the cosine of 118 degrees. So therefore, x squared is approximately 118.84. I'm going to take the square root of my answer. So therefore x is approximately, they only give me one decimal place, so I'm just going to use 10.9. So that is the, how far is the ship from port. Now the bearing, whenever they're asking for the bearing, you from your original location. So from this point, what is the bearing from port? So if they were going to send a ship to find you, what will be the direction that they'll have to send from the port and tell me, go 10.9 miles into what direction? So therefore, we are looking for this angle here. Well, we know that that's 28 degrees. So therefore, I just need to be able to find this angle here and add it to 28 degrees to be able to know the bearing of your current location that you are here. So therefore, what should I use? Well, I already know that this is 10.9. So therefore, I have my opposite angle and my opposite side. So therefore, I can use my law of sines. So let's go and label that as angle theta. So we're going to find theta by using the law of sines. So it will be the sine of theta over 4.3 is equal to the sine of 118 degrees over 10.9. So therefore, the sine of theta, multiply both sides by 4.3, will be 4.3. The sine of 118 degrees over 10.9. And now I can just tap into the calculator, and that'll be my angle. So therefore, the sine of theta is approximately 0.35. I'll find the inverse of my answer. It will be theta is approximately 20.38 degrees. Now that is not the bearing. And now one of the things that I should go back and do, since I have 10.9 in here, I probably should have done my answer. Since I already have it here on the calculator, now one of the things that we want to make sure is that it's a little more accurate, so I should have just done this instead. You notice that it doesn't change my answer much, but just be careful, sometimes it does. So therefore this is 20.38, so therefore the bearing, so the ship is 10.9 miles from port with a bearing now of 20.38, but 28 plus 20.38, which is 48.38 degrees. So therefore, if you travel 8.2 miles in a 28-degree bearing, then you travel east for 4.3 miles, you can tell them to go find you. If you get stranded here, they're going to go for 10.9 miles with a bearing of 48.38, and they'll be able to find your location. Example number 12. We're going to take the time to copy it down, and then we can work it out. So a plane with an airspeed of 192 miles is headed with a bearing of 121 degrees. Now a north wind is blowing from north to south at 45.9 miles. Find the ground speed and the final bearing. So let's make it x and y axis. And we want to be able to start at the center just so we have enough space. Sometimes you might have to redo it if you need more space above. But in this case, I think hopefully we won't. So a plane with an airspeed of 192 miles is heading on a bearing of 121 degrees. So let's see, this is 90 from the north towards the right. 90, how much more? 31 more degrees. 20, so around here. Now the next one will be, this is 192, the next one will be much shorter, so I'm gonna make this one a bit longer. So either here or here. You wanna make sure that you always get to the grid, so I'm just going to do it, place it here. So therefore this angle is 121 degrees. That is 90 plus 31 more. This angle, this side is 192 miles per hour. Now, a north wind is blowing at 45.9. So therefore, there's going to be wind that's going from the north towards the south. So notice that whenever it says a north wind, it's going from the north towards the south. So as you do your homework, just be careful. If it's a south wind, it comes from the south towards the north. If it's a north wind, it's coming from the north towards the south. So therefore, and I probably just need a little more space underneath. I'm going to place 45.8 and I'm going to extend my plane. We'll make a little more space for myself. So we have from the north towards the south, and now the wind is going to be pulling all the way through it. Now remember that the wind is going to be a vector, and vectors can be moved any way through, so we're going to place it at the very end. We're going to place it over here. And it's going to be 45.9, so I'm just going to go to the next grid, so around here should be fine. And this will be 45.9. Find the ground speed of the final bearing. So therefore the plane is going through here towards this direction, and the wind is going to push it towards this location. That's where the plane is going to end. Now, because it's kind of pushing the plane is going to go a little faster. But one of the things that we need to do, so we need to be able to find this is going to be the distance, actually the speed of the plane. Even though it's supposed to go 192 miles per hour, the wind is going to help it go a little faster. So therefore that'll be the new speed. So at this point, I need to be able to find one of the angles, either this angle, that angle, or this angle to be able to find the value of x. To do so, we are going to use our right triangles. So I'm going to extend this side and I'm going to place it as dash. And I'm going to extend this side and I'll place it as dash. And probably should place my x and y axis as dash as well. And this is a right triangle and that is a right triangle. So that's going to either help you find this angle, or that angle. Go and pause it, see if you can find the corresponding angle. This one here, A, B, or C. You got it? Okay, so there's different ways to think about this. You can think of this being 121, so this is 90 plus this angle here should be 31 degrees, or it is 31 degrees. And you can say that this is 31, so therefore this is 59, because that makes it to 90. So therefore this angle here will be 180 minus 59 will be 121. And now we can use the law of cosines. Since we have two sides and the angle in between, then we can use the law of cosines to find x. And that'll be the final speed of the plane, and then we can just find the bearing just like we did above. So let's go and find x. So find x and see what you get. Go and pause it, and then we can continue. So this is x squared is equal to 192 squared plus 45.9 squared minus 2. Some of you guys will forget the 2 on your test. And the cosine of the angle in between, which is 121 degrees. So from there, I can just type into the calculator. And the cosine of 121. So therefore, x squared is equal to 48,048.67. That's approximation. I'm going to take the square root of my answer. So therefore, x is approximately 219.2. And they have no decimal places, so I'll leave it as 219. And this will be miles per hour. So that is going to be the speed of the plane. So even though it took off 192 miles, the wind is going to push it forward a bit. So it's going to go a little faster. And now I just need to be able to find the bearing of the plane. So therefore I need to be able to find from here all the way up to that angle there. So therefore I just need to be able to find this angle here, add it to 121 degrees, and then that'll be the bearing. Go and find it and see what you get. So find theta. So I'm going to use the law of sines once again. So this is 219. So it'll be the sine of theta over 45.9 is equal to the sine of 121 degrees over 219. So therefore the sine of theta is equal to 45.9, the sine of 121 degrees over 219. And I'm going to type it into the calculator. Notice that I'm going to leave my answer here that I have before. So therefore will be the 45.9, the sine of 121 over my answer. So therefore the sine of theta is approximately 0.18. I'm going to take the inverse sine of my answer, and theta is approximately 10.3 degrees. Now, one of the things that you'll notice is that I'm not looking, even though I'm looking using the law of sines, I'm not looking for the ambiguous case because there's already an angle that's 121 degrees, which is bigger than 90. So there's no way that there's going to be two triangles. So therefore, the ground speed for the plane is 192 miles per hour, excuse me, 219 miles per hour. And bearing is not 10.3, it will be 10.3 plus 121, which is 131.3 degrees. Let's go through one more example. Example number 13. Problem number 13. So problem number 13. So go and copy it down, see if you can make a sketch, and then we can continue and see if we did it correctly. Go and pause it. So a plane travels west for 79.4 miles. So let's go and place our x and y axis. So it's going to travel, so we have never eat soggy waffles. Or the other one is correct. But now, it's going to travel west for 79.4 miles. So it's going to go from here. It's going to travel west. And that'll be 79.4. Now, from your new location here, we want to place another x and y axis. So let me just place it as dash this time around. The plane then travels 124 miles at a bearing of 49.3 degrees. So therefore, from the north towards the right, it'll be 149. So this will be 90. How much more to get to 149? So almost 60 degrees more, 59.3. So it'll be around here. Now it's going to be longer or shorter than 79.4. So it's going to be longer. So I want to make sure that we don't know for sure that's going to be on this line. And I think sometimes the mistake that people make is that they might place it here thinking that that's a 90-degree angle. So I'm just going to go either past it or before. In this case, I'm going to go past it since it's 124. So this is 149.3 degrees. This is, you start here. This is your starting point. You go towards the west, and then you make a rotation from the north towards the right. And now we want to be able to find how far is the plane from the initial point. We're going to find x. So we know that this is 124.6. So see if you can find x, and then we can check our answers. So first, remember that you need to be able to find one angle, either this angle here, this angle, or that angle, to be able to either work with your law of sines or the law of cosines. Can we pause it? Correct. So this is one of the easier ones because you know that this is 90, so therefore we know that this is 59.3 degrees. And now because we have two sides and the angle in between, I can use my law of cosines. And I'm going to look for x. And in this case, we don't need to find the bearing. So once you find x, we'll be done. So therefore, it'll be x squared is equal to one side square plus the other side minus 2. The sides repeat. And the cosine of the angle in between, which is 59.3 degrees. And we're going to type into the calculator. And I can type it in all at once. And the cosine of 59.3. So therefore, x squared is approximately 11727. I'm going to take my square root of my answer. So therefore, x is approximately 108 point. Do they have one decimal place? So I'm going to keep as one decimal place. So therefore, the plane is 108.3 miles from its initial position. So work on your homework and email me if you have any questions. Have a great day, and I'll see you guys next time.